Would Jason, you'd really like to review it. It's very important in a sense, like selection structure is one important thing, right? Selection structure, if else, and switch case. Okay, we will learn if else switch case, input function, fprintf function, and so many other things. Next class, we had two more examples, so means like we get lecture two, we get lecture two. So if you're gonna notice in Brightspace, I do have this lecture.m file here. We get lecture two, as you can see here. The video lecture is as well over there, so gotta you gotta watch. Okay. Okay. All right. So the lecture is going on. Ben obviously is missing today. I'm hoping Ben will gonna watch everything and the video lecture and the .m file. Okay. All right. So about the other stuff of this class, let me make sure. Okay, the screen. Okay, now the screen will be recorded. So about the other stuff, the assignments. Let me go to the assignments and then you see. I'm expecting this tool will be uploaded from you guys today. Homework 8 and practice 8, right? What is that? These are the selection structure. Okay, you might have to work a little bit more today, Jason. And this week, week 9, we are homework 9 and this practice 9 are uploaded again. Those are due next week on Monday. Any questions so far? It's good. Okay, what's up? Homework number? What, like homework number 8? All right. Okay. You're not sure how to do that? So it has this true range, right? So you wanna okay use find to create a function called f. This is with the following. Okay, so you can so many ways you can do. One thing that you can do, you can use a user different function. You can do a user different function f. That's what it says, right? So create a function called f. So you can create a user different function f, and on that function itself, you can put whatever in input function that you did. Remember that find function. Sorry, whatever that you did in find function, you can did that inside that. If it confuses you so much about the user different function, don't worry. Just make a .m file. No user different function. Just create a find. Create a .m file with this find function only. Okay. Don't worry about the user different function or .m. Okay. Another question? All right, perfect. Moving on to our agenda today. So, where is my code? Octave code. Yep, here. So I want everybody to start typing what we're seeing here. Okay. There's the intro stuff. Again, on intro stuff, it says here what is the agenda for today's class? It's a for loop. Okay, and then explanation of that, and the CSC, clear, close, all those things. Okay, well, why don't you finish those typing, and then we'll all start typing together. Okay, maybe a little smaller. Let me make it a little bigger. You may see it better now. Okay. Let me um, you can the practical example for this class would be sample with the grades, right? So you can do this way. See, the class not three students, say like 30 students, right? Each person, I mean, how many homeworks you had? Like 10-ish, actually more than that, 12-ish, right? So 12 homeworks we had, 12 practice problems we had. This class has two exams. Say like 3 or 4 exams we had with all 30 students. So many data, right? And you'd like to compute the final grade. Okay, so for each of the students. Now, how going to do that? I mean, you can't just pick individual data, right? Every time the calculation is going to happen for each student the same way. Make sense? So if there are like 30 students, you can declare a for loop where the for loop is going to run 30 times, right? And you're going to run the code just one time where it is going to calculate the final grade. With the data, including the homeworks, practice, exercise, exams, whatever it has, right? Makes sense? You just write the code one time, like the actual competition, right? And you are running it for 30 times for 30 students. That's what for for loop. Makes sense? And while loop is kind of goes similar to this. But the class today, I have the for loop starting, and then we'll have like 3 more classes. So basically, for loops is for 2 weeks, like 4 classes, right? So it's a very important concept. The same thing is for the while loop. So basically, from this point on to end of the semester, pretty much you'll be dealing with for loop and while loop, and at the end, very end, we'll have the symbolic map, the symbolic map, like the algebra that we do. Okay, and then we'll be done. Okay, now come back to the for loop again. So for loop, the class in this class, you'll be seeing me giving you the basic syntax, means how to call the for loop. Okay, basically by notes, I'm gonna give you those basic syntax. How to call the for loop? What are the syntax for starting and end of the loop? What are the syntax for the condition of the for loop? Right, those sort of things. And then I have just 2 more examples at the end, and then the class will end. Since we are only have two students today, and if the typing speed goes well, everyone understand this class may end very well in 30 minutes. Okay, okay, that's our goal. Let's see what happens. And for Ethan, it's like probably a piece of cake, right? Ethan, you have done so many follow-ups, I'm assuming, in different programming. All right, so let's just go with this. After this that you are done, let's start with the definition of the loops or for. Let's start with the loops definition, and then the for loop will going to come. So it is a coding structure where a calculation or operation or set of calculation or operations set of calculation or operations sorry all right, perfect. Operations is or are repeated multiple times. As I was explaining, a loop is a repetition structure. Okay, and the question with the follow is basically a repetition structure where you'd be doing the same math again and again and again until you decide like how many times you'd like to do. All right, so more syntax about the for loop itself. So all for loop consists of 5 basic parts. What are those? Number 1, a parameter to be used in determining whether or not to end the loop. Okay, basically the condition when to end the loop. If you'd like to run it for 30 times for 30 students, that's what it's referring. Okay, number two. Okay, you gotta initialize. That's very important. Initialization of this parameter. The parameter that would be used when to end the loop, you gotta initialize by a variable. So like if the number of students is I should be I equal to 1 to 30. Okay, so that's something. Okay, you would like to initialize that parameter. All right, you wanna do a way to change the parameter each time through the loop. Okay, so basically in the loop itself inside the loop, you gotta keep increasing the value of the I. So next time when the loop will gonna run, the next operation will gonna done for the next student, right? The example that I was giving. So basically the way they do usually I equal to I plus 1. You keep adding one value of I every time. So like I equal to probably 1 index number for student number 1. I equal to I plus 1 means then I equal to 2 in the next step of the for loop, so student number 2, right? Because 1 plus 1 is 2. So then the next step would be I equal to I plus 1 again, means I had 2 value, then 2 plus 1 is 3. So that way I value is going to keep increasing, right, inside the loop. That's what it says. Just you understand what I'm saying? So inside the loop, you are increasing the value of the I. Okay. So if the value of the I initial is 1, and the second time when the loop is running, Ethan, you might know already what I'm saying, right? Second time when the loop is running, you are doing the math, say I equal to I plus 1. What is the value of the I before? 1. So then the second step, second time when the loop is going to run, now the I value would be what? 1. Before it was 1, right? I equal to 1. 1 plus 1 means 2, right? Now the I value is 2, second time, right? So the loop is end. Now it will going to run again, right? Because the condition didn't met. So then the third time when the loop is going to run, it will going to update the I value, and it will going to come across with the same equation, I equal to I plus 1. What is the I value? Second time the loop was running, 2, right? So then the new I value would be what? 2 plus 1, which is 3. Okay, so the I value is going to keep increasing until the end of the program. Does it make sense? So that's what it says. Okay, number 4, a comparison. So a comparison using the parameter to a criteria used to decide when to end the loop. And it's also very obvious, right? You gotta decide when to end the loop. Like basically, you'd like to compare when the I value. See, remember the I value keep increasing. When the I value will gonna match to certain value, say like number of students 30, right? When it does the comparison and say, okay, I value is now 30, so I'd like to end the loop, right? So that's the comparison. It needs to be done every time the loop will gonna run. Okay, we'll be seeing in practical example as well. So number 5, okay. You'll have to do a calculations or operations. Okay, what does it mean? Calculation or operation means, remember, you're calculating the grade, final grade for the students, right? Operations to do inside the loop. That is your whole goal, right? To calculate the grade of the students, right? And that's what you are doing here. And then obviously, let me put some more notes here. So see PowerPoint. Now I'm not going to show you the PowerPoint for the flowchart. I used to do that, but I'm going to talk about the flowchart at some point. So let's start with the for loop. Okay, for loops. That's the basic structure of all loops, right? It could be while loop, it could be for loop, and there are other loops as well. Okay. So with for loops, let's start with an example. By the way, whenever you have double percentage sign in MATLAB, that creates a section. However, in Octave, it doesn't recognize anything. Okay, but you need to know what double percentage means. Okay, you'd be probably using MATLAB, who knows, during the job, right? The Octave is free program. Okay, example. So example one, a simple for loop. So n equal 10. That's the criteria, how many times the loop needs to be run. Okay, so this is the number of times we want the loop to execute. Okay, and then the for loop will gonna begin. So remember, I was talking about it, right? So you need to assign a variable. In this case, it is I. Okay, and when the for loop is gonna start, you gotta put the condition how many times the loop will gonna run. So you are defining the variable I, and you would like to define the value of the I from 1 to n, because this capital N that you have decided 10 is that many times you would like to run the loop. Does it make sense? So capital N 10 is referring that. So basically, you'd like to write it this way: 1 colon n. Now at this point, everybody know what this colon means, right? You know, you defined the matrix. Just remember that by using that column. Now here's the thing: if the matrix has interval of 1, in this case I has interval of 1, you can remember how to do that. You don't have to write 1, right? After this 1 colon 1 colon 10 or something like that, 1 colon 1 colon n, you just have to write 1 colon n, right? And is as if like it's hinted, because it's the interval is 1 by default. Okay, you're defining a matrix where you'd be saying, okay, run the loop for 10 times. And then you want to put some note here and around it. So this I is the parameter. Okay, so this line initializes I at 1. Okay, and makes it change. The note is a little longer. On each loop iteration. Okay, it also compares the parameter, okay, to criteria, and in this case, right, capital N, I can be any variable, but common one are I, J, K, L, M, N. You got it? Where this Y I needs to be I multiplied 2. What is that we're doing here now? I had so much of the text over there explaining what is this I, what is this 1 column, and I did explain it as well. Now this line that I'm showing it to you here I'm creating a matrix called Y. Okay, and this matrix, we're gonna have the values keep adding after every time the loop is gonna run. So this matrix element initially is y1, which is the first element, is equal I equal to 1. 1 multiplied 2 is 2. So the y1, or the first element of the y matrix, will be 2. Make sense? Then the second time the loop is going to run, so then the I value will be 2 in this case. So that would be the second element of the y matrix, which would be y2 equal 2 multiplied 2 is 4. You see what I'm saying? The third time when the loop is going to run, the value of the I is 3. So that would be the third element of the y matrix, which is like y3. Remember, Jason, like y3 equal I multiplied 2 means 3 multiplied 2 is 6. So the third element of the y matrix will be 6. You see, this way this is going to run until the y value will be what? 20. 10 times it will going to run. Does it make sense? Because the capital N is 10. All right, so let me put the note here. So you're going to put any type of calculation in here. Make sense? And then you're going to simply end this. Okay, if you forget to put the and, it will not gonna run. It's true for the if else statements, switch case statement, any selection structure, any for loop, while loop. Okay, in any place you gotta put an and. Make sure you put an and then you can actually run your first for loop. Okay, you can save it. Okay, I'm gonna do it like week 9, lecture 1. Okay, I'm gonna save it. I'm gonna run it, and I'm gonna see what happened. All right, you have a syntax error. Let me see, what did I do? Oh, I forgot to put a equal sign. Sorry about that. Let's see. So now I have the value of the y. Now, interesting fact is, like, since I didn't put a semicolon, what is happening here, Jason? Every time the loop is running, you're going to have the value before it giving you. Now, if you're going to put a semicolon, and then you will be seeing that way, but once you run the program, and then type y in the command window, we're going to show you the last line. Make sense? Try it. So what I'm going to do next, I'm going to put a semicolon and see what happened. Obviously nothing will happen, means nothing will gonna, something will happen, but nothing will gonna show up though. So let's come to the command window. So it's empty, right? But you type y, you see the last line will gonna show up. Make sense? Is anyone understand? Good. All right. So I can actually now explain each and every line that I did here in terms of the syntax. Okay, it would feel like a little boring, but please, for the first time, if you're dealing with the for loop, it could be important. For Ethan, it could be like, really not that important. Jason, you're dealing with the first time for loop. I'm gonna now do like each and every line that I wrote along with the 5 steps instruction that I have. I'm gonna try to correlate them. Okay, let's do it. It's important for you, Jason. Okay, so let me start doing it here. So for loops are the simplest loops. We can typically create them with 4 basic parts. Okay, so from the example above, let's define, as I was explaining, okay, all those 4 steps, how those are related. So number one is define the criteria. So define the criteria that sets the number of iterations. Okay, and then you have this capital N equal 10. Number 2, you understand, right? Capital N is define the criteria. And okay, for statement in the form for parameter. So you see the way I'm writing, for I equal to 1 colon n, that's what I'm explaining. For the parameter equal 1 colon criteria. So the parameter is always set equal to a matrix that increments by 1. Okay, as an example, 1 colon 5 or 4 colon 25. Makes sense? So the increment would be 1. Okay, and it doesn't necessarily need to start from 1. It could be start from, as you see in second example, 4 colon 25. What could be the application? Say maybe the class example, great example that I was giving. Maybe first 4 of the students, you already have the grade calculated, or don't need to calculate the first 4 people's students' grade, right? You'd like to start with first 3. You'd like to start with 4th student, right? So in this case, you'd like to say, okay, and total number of students 25. So then you'd like to run this loop only from 4 to 25. And the 4 and 25 is the index number. You understand, Ethan? So these are referring to the index number, okay? For the matrix of the grade, in this case, for the class. Does it make sense? Okay. And this one is so important in application. So then with the example here, so remember for I equal 1 colon n, that's the thing that we've seen, right? And then number 3. So you're gonna do the calculations to do inside the loop. Okay, in our case, what is the calculation? Y equal I multiplied 2, okay? And then if we just use y, the value will be replaced on each iteration, okay? All right. I did explain all of this, right? So then let's explain a little bit more. So remember, this y matrix has this element I in the parenthesis, can be written as I multiplied 2. In this case, if we use any initial notation, we build a matrix in the loop, okay? Tell MATLAB or Octave where the end of the loop structure is, okay? And then have this end. I have 2 more examples and very small examples, and then we'll be done with the class. Okay. Any question so far? Any question? Both of you understand? Ready for the second example? Perfect. Example number 2. Example number 2. So we'd be add up the numbers from 1 to a value specified by the user. So n equal input, you want to do number you want to add integers to, and then you guys remember the input function. So remember in the previous example you define, like, how many times the loop needs to be run by defining the capital N, right? So before you run the program, you defined it. Now in case, say, like, you don't know how many times you'd like to run the loop, so you're gonna define this way, say like this capital N, by using this input function. So that means when you're gonna run the program, they're gonna ask you how many times you'd like to run the loop, right? Instead of you defining the value of the N before, right? Instead of the number of students that you defined, the example that I was giving, like 30 or whatever, right? You understand? So there's the input function here. And then moving on, so you would like to define this. The first time you are doing something called, say, like total variable, which is 0, and then you'd like to define initialize counter variable. Okay, and then for j equal 1 colon n, and then you're gonna do, I'm gonna explain it what is this total. Just 1 second, let me finish that. J, and then you are adding the parameter value to total. So total each loop iteration, right? And then you're gonna end this, and then you're gonna print it, f print f. Okay, you're gonna print the results, and you're gonna say the sum of all the numbers from 1 to percentage of point 0 f is percentage of point 0 f, and then full stop and /n, and then you're gonna define these two variable, capital N and this total. Okay, and you'd like to save it and run it, but before you do any of this, let me explain what we did here. First of all, the input function as explained, right? How many times you'd like to run this thing. Okay. Secondly, here first time we're using this total variable, and defining the value of the total variable as 0. Inside the loop, we'll keep adding the value of the value of the I or j in this case, right? Keep adding the value of j with this total, and whatever times the loop is gonna run, and this j is gonna keep adding up with this total. Initially, the value of total was what? 0, right? So like the loop is running first time. So 0 plus j value is 1, right? So 1. So the total value will be what, Jason? 1, right? So the initial value of the total was 0, right? Initial is 0, and the j value keep increasing inside the loop, you know that. So first time the loop is running, j value is 1. So now total is 0 plus 1 means total is 1, right? So the second time when the loop is gonna run, total already have the value of 1. So it is gonna be 1 plus what? 2, so 3. Now the total value is 3. So third time the loop is gonna run, total value will be 3 plus 1 again, right? Make sense? So it will be 4. This way it is gonna keep increasing, right? And then the loop is run after whatever times you'd like to run, then the input. Then you'd like to display. Fprintf is the perfect means to do the display. What you have here, you'd like to say, okay, the sum of all the numbers from 1 to, you are not saying like how many times it's running, because you did remember define the and by input function, right? And you don't know before you running the before you typing the code, right? Before you running the code. So basically, you gotta use a pointer. I did a mistake here. You see, percentage of OF should be 0, percentage of 0. If you're gonna use this O, then it will not gonna run. Everybody got it? There's a type, it should be 0. The percent is a pointer. That is the placeholder for the variable value to come. So that's the syntax. That's the reason you want to put a percent. And then f is a fraction, right? The value is fraction. Now you are going to define, say like after percentage 0.4 or 0.0. That means you don't want to take it in fraction value. Why? The number of times the loop is running, it doesn't go in fraction. It is an integer, right? Numeric number, integer, makes sense? So it can be in fraction. That's why you are putting this 0.0 or 0.0. Makes sense? They're only in fraction. So that's about the n, and then the total will be going the same way. Because see, total is 0 before, and since the j value couldn't be anything other than the integer, no fraction is allowed. So total will be with also no fraction. That's why you are putting 0.0 again. Make sense? And this percentage is for the placeholder, because that's the place where this variable n or total will gonna show up. Okay, that's why it's called placeholder. Make sense? Inside the Fprintf. And this is part of the Fprintf. Huh? Which one? percentage is it's a syntax. The percentage is syntax. Syntax means you always put a percentage in f-printf function, not everywhere. In f-printf function. The f-printf function is a function that requires percentage as a placeholder wherever you'd like to display any variable. Here, n and total are the two variables. Now you can't write n and total inside this code side, because remember, code inside the code, whatever you're writing the text. It needs to be outside, right? So that's when the code is finished and you put a comma and you put those two variables in. Make sense? The n and total are the variables. You can't put it inside the code. You're gonna put this inside the code. It is gonna display as like a text. It has nothing to do with the variable. Now you'd like to show the variable value inside the code, so that percentage of f or percentage of s or percentage of whatever is a placeholder which is going to correspond to this variable, in this case n and total. Does that make a little sense? This f is a fraction. That's again the same. So if you are using the fraction of the number which is fraction, then you will use that. Remember, in one class we use percentage of s. If you'd like to use that percentage of s, then it is going to show a character. Right? Remember, we had it. I forgot now. What is that? In one class we had an example when we were showing a printf the character. I forgot. Like, you remember where the shorts or this sort of thing, right? We use the percentage of s. Now in that case, s is the string. String is the text, right? Then your variable was like string. That's why you use percentage of s. And there are other things like after the text, percentage of f and s. I don't know all of them also. If you'd like to learn more, basically go over to how after that you should see more detail.
So where is the f in this?
Where is this f in this case? Yeah. This f here you see is representing this value. Okay. This f here you see is representing this value. And this percentage is locating, that's the place where this value is going to show up. This f is saying this is a fraction number. And by using this point O, you are defining, okay, don't use any fraction. It's conceptual, okay? You know what I'm saying? Because these values shouldn't be any fraction, right? The j is not a fraction. It starts from 1, right? Okay. Any question? Any more? Ready for the next? Okay, you would like to run in and see what happened, right? Okay. There's the error. Invalid. What did I do? I have this total. Oh yeah, I know. There should be equal. I put minus. Sorry about that. You want to correct it? J equal. It's probably running for you guys, right? Okay. All right. Now it says, okay, how many times you'd like to do? So 40 times. Now it says the sum of the numbers 1 to 40 is 820. Okay. See if it's done for you. If not, let me know. I'm going to come. And the last example that we'll be doing today is example number 3. So on this example, let me give you a little brief. We're going to count the scores satisfying a set of criteria in a loop. Okay, and then scores, obviously, the variable that we'd like to define. And then scores means the class score, I mean the test score, whatever. But those values are random. I choose here, say like 76, 40, 98, 97. Okay, those are, say, like the homework scores or the test scores. So these are the scores. You'd like to put a note here, possibly from a test. Okay, like 4 students there. So then count is a variable that you'd like to define equal to 0, and it's the item counter, right? and then you'd like to define capital N equal length and then scores. What is that we are doing here? First of all, we define a score matrix, okay, and number of element on that score matrix we don't know. I mean, we do know we typed it 4 times, but the code doesn't know how many times, right? What are the elements, number of elements for that matrix? So this length function. Anybody remember the length? Did I use the length function before even? Maybe not. So this is the first time we use it. That's a very important thing. From this point on, let's you'll be seeing me using length function all the time. At some point, you would be using it all the time also in homework and other places. What is the length function? Length function we're gonna find how many elements a matrix has. In this case, the scores is a matrix. How many scores there? Test score like 4 there, right? So the length is gonna give the value 4, right? What is the importance of that? If you know how many times what are the number of elements for that matrix, then instead of, remember last 2 times, first time we defined the value of the n, capital N, with the value 10. Second time we are asking the user how many times you'd like to run the loop, right? By using the input function. And this time, if you're using the length function, it is going to tell me how many times the loop needs to be done. It makes sense? From the score matrix. As if like, how many times the value of the score value is there, the loop will gonna run. Does it make sense? All right, so that's that. So that's your N, capital N. And then let me put some note, obviously. So your loop will repeat for as many items as are in scores matrix, right? And then last few lines that we're doing here. So like for k, this time remember this variable initialization variable could be defined I, j, k, l, m, and those are, let's use k here. These doesn't need to be those, it could be literally anything, but these are usual convention. So k, is 1 colon n, capital N, obviously. Make sure you put capital N. And then k is the parameter here. This time I won't be writing too much because you see we did already. And this time we'll be using the selection structure inside this for loop. Remember the if, so it's like called cascade loop. Does it make sense? Selection structure like if else, you've seen that before. So we're going to use this if scores, the value of the scores, and put k inside the parenthesis, means the element of the score is greater than 90. Okay, and if the kth item in scores is greater than 90, that's what it means for, right? Then you want to write count equal count plus 1. Okay, and then you're going to put some notes here. So it will gonna increase the item counter if grade is greater than 90, right? And then you're gonna simply end this if else statement selection structure and end this loop as well. Okay, so let me put a note here. So you are, by putting this and if statement, right? And you are putting this, and you have two of this statement here. That one would be and for loop. Okay, and you'd like to print the result, so f printf, and then you'd like to display the result this way. The count is, remember the percentage thing, 0.0f, not of. /n means the cursor will be in the next line, and then you're going to simply type count, right? That is the variable. I'll save it, you're going to run it, it should be displaying you so far. it should be displaying you how many times. So the count is 2, means 2 times the score, test score is more than 90, or in other words, 2 students get more than 90 out of these 4 students. Okay, and finish the typing. I'll explain it again. Okay, think about it. What is happening here? So this one is a little tricky because inside the for loop we use the if else statement, right? So we didn't have to use the if else, we just have use the if and, right? Because if the score is more than 90, then you are keep increasing the count. Now what if, like, you have assume a scenario, this is like very simple case, right? You have like 4 test scores, right? 4 students. What if you have like 100 students, right? All sorts of things can happen here. It's not necessarily only 90, above 90. So like you have above 90, you have about 80, about 70, about 60. We'd like to see how many of them get A, B, C, those sort of things, right? So what do you want to do? I mean, to change it. First of all, the scores matrix that you have here, in that case, you'll have how many elements? Not 4, right? 100 elements. Because you have number of students, what? Jason? 100, right? So out of 100 students, then you would be doing pretty much same as it is, right? The n would be still 100. This you understand, right? So inside the for loop, what is going to happen? Inside the for loop now, you would like to do if else, if else if, why? Because in the first if condition, you'll be putting the similar thing, like the scores, okay, is more than 90, and obviously take a note here, if scores, and then inside the parenthesis you have a k. It makes sense. So as if like every time the loop is running, you are comparing that particular element of that matrix. Now remember, the score matrix has 100 values, right? Each of them is one element, right? So when k value is 1, it's as if like you are getting the first test score, or the first student test score, right? Because score 1. Okay, the second time loop is gonna run, it is gonna be second student's test score, which will be score 2, right? So now I was just saying, like, you don't know, the first student score could be 50, right? Now this one is simplest. It says, okay, if it's above 90, you count it. Okay, that's it. Then how many of them get A? But what if you'd like to compare it and see if the students get, how many of them get B, how many of them get C? That's the thing that I say. So then this thing can be extended this way. So you should have the second thing here inside the for loop, else if, and then you should be writing count k is greater than 80 and less than 90. Does it make sense? Greater than or equal to 80, less than 90. So you should be putting another condition like that. This means the last class we had an extensive example. Okay, please review the last class where we had more examples here, right? That is statement, you know what I'm saying. And that way you're gonna keep adding, and finally you could have shown, like, instead of count, in that case your variable could be like, grade A, then grade B, and you would be defining them grade A 0, grade B 0 before even running any of these, as if like you define count equal to 0 before, right? Do you see that? You understand? There's a hypothetical scenario I just explained when the program could be a little bit complex. But this one is the simplest program. Why would we seeing, like, out of these 4 scores, how many of them get more than 90? It's so straightforward, right? Everyone understand? Is it running for you? Jason, you understand? Is it running for you?
So it says like, it says count equals 1.
Your count is equal to 1?
So where did that come from?
Your count should be 2. Because the scores,
I have like,
So basically, that's every time it runs the loop, it's going to increase the count by 1,
I'll bet.
and it's going to display
I mean, when it says the value is more than 90, there are like 4 values.
when condition.
One condition met. When condition met, and the condition you decided, the score needs to be more than 90. Right? Understand? So it should be 2. If you're getting 1, then you.
that is, yeah, the one job is
You're getting 2 result.
yeah.
That makes it good.
You're getting the correct. It's just showing you every single time it increases.
And you'd like to put a semicolon inside this. Okay, that's very important thing. You like to put a semicolon, obviously, and always end of the loop you'd like to display the result by F printer. That's the trend. Now, FPrintf is so important. Land function is so important. From this point on to end of the semester, you'll be using all the time. So it's better for you to be master on those things. Make sense? FPrintf and this land function and this app equals. I mean, this is just a starting class. Think about this way. For loop will be doing 3 more classes, right? While loop will be doing 4 more classes. 7 more classes will be doing the similar stuff. But after a few weeks, you'll be master on this. Okay? As long as you come to the class and do the homework sometime and keep attention and everything, okay? I wish Ben, if you're gonna see Ben before the next class, please tell him to watch this video lecture and everything, okay? Otherwise, he's gonna fall behind, okay? I don't know any of my students in that situation. If you don't have any question, I'd like to end the class here. Okay? I'll see you again. Yes, I'll come back in just 1 second. Okay, so let me do this housekeeping stuff.